Guys, how are you? Today we are going to discuss DPP Module 9. Let's start it off. And our question is 29.2% weight by weight percent HCl stock solution has a density of 1.25 gram per milliliter. The molecular weight of HCl is also given, which is 36.5 gram per mole. Now, the volume of stock solution required to prepare 200 ml solution of 0.4 molar HCl, which has molarity of 0.4. Now, the question once again repeat this question. 29.2% weight by weight percent HCl stock solution has a density of 1.25 gram per milliliter. The molecular weight of HCl is 36.5 gram per mole. The volume in milliliters of stock solution required to prepare a 200 ml solution of 0.4 molar HCl is asked here. So for solving this question, so first of all, weight by weight percentage. I already taught this in basics classes of chemistry, which is the first video of our channel. In that, what is meant by weight percentage, I already taught. In case you didn't listen, I will once again teach you. Weight by weight percentage means in 100 grams of that solution, uh, that given weight by weight percentage, that means let's say x weight by weight percentage is given in the question, then it means that in 100 grams of that solution, x grams of solute is present. Okay, now here we are given that 100 grams in 100 gram solution, it was given that 29.2 gram percentage of uh, weight by weight percentage of HCl was given. That means in 100, sorry, that means in 100 grams of solution, 29.2 grams HCl is present. Also density is given, which is 1.25 gram per mole, sorry, gram per milliliter actually. Now also molecular weight of HCl is given, which is about 36.5 gram per mole, and we are asked to find out the solution of, the volume of stock solution required to prepare a 200 ml solution of 0.4 molar HCl. Now first of all, with these, let's solve the question. Now volume of given solution can be found by mass upon density, because density is equal to mass by volume. That implies V is equal to m by d, which is mass by density. I hope you understood. Now let's solve this. Now mass of the solution, let's say 100 grams. We already, weight by weight percentage means we took the solution weight as, considered solution weight as 100 grams. Now in that 100 grams, density is given that 1.25 gram per milliliter. So by solving this, we'll be able to get 80 ml. Yes, of course, 80. Now the volume of the solution was found out, which is 80 milliliters of the solution given, not the stock solution. We should find out the volume of the stock solution. This is the volume of the solution. Now uh, we found out volume, and molecular weight of HCl was given, density was given, and also weight by weight percentage, which means in 100 grams of that solution, 29.2 grams of HCl is present. And now we have molarity formula as mass of solute by molar mass of that solute into, here we obtained volume in milliliters, that is 80 ml actually. So into 1000 by V in milliliters. If it is in liters, then it becomes 1 by V. So in case of milliliters, we write this on 1000. Otherwise, we write it as 1 by V. Actually, the formula is 1 by V. So it is 1000 by V in milliliters as of now, because we found out volume in milliliters. Now mass of solute, which was given 29.2 grams by molar mass of solute was also given, that is molar mass of HCl was given, right, which is 36.5 gram per mole. Now 36.5 into 1000 by, we found out volume which is 80 milliliters. Now if we cancel out this 0 and also 4 2s, 425s, and 5 in 5 table, it goes 5 times and it goes 7.3 times. Yes, 7.3 times. Now 29.2 by 2 becomes 14.6. Now 7.3, 14.6 was 2 times. That means 2 into 5 here. Here 1 5 is present, here 2 is present, so 2 into 5. Total we are getting molarity as 10 molar. This is the molarity of the given solution. Now we should find out the volume of the stock solution. So in order to find volume of the stock solution, we should also know a concept which is dilution. Actually, I'll explain you in a clear way. Let us say we are having two beakers. No, let's take a beaker. Sorry, we are having a beaker, and in this we are having some solution. It in this uh, particular solution, mass is m1 and number of moles of solute is n, let's say, and volume is v1. If we add some water into it, that means up to here the water level is present. In this beaker, in this particular beaker, we are adding some water, so that now it becomes now it becomes, yes, right, everybody is understanding, right? Now if we add water, it levels increases. That means in this particular solution we'll have some mass m2 and number of moles will be same, because I'll give you an example. If you take some water bottle, in this, some up to some content water is there, in which let's say it's lemon water. Here the solute becomes lemon, right? Lemon's liquid, right? Suppose lemon's liquid is some n number of moles of liquid is present, n number of moles of solute is present. If we take this cap off, first of all, Now if we add some water into it, suppose it level becomes up to here, let's say. If you add some water into it, does this concentration of only the concentration of the liquid changes, but the number of moles of solute remains same, right? If you, I'll give you another same in another way. Like if you are dropping out this solution, that is, if you are dropping out the solution present in this, then the liquid up to here, let's say here, yes, up to here. Even when we pour out the water from the bottle, the number of moles of solute will remain same. They will not change at all, because when we pour out or when we add some water, only the thing changes are mass and volume, right? Which means concentration. Only the thing changes are these. This will be constant. I hope everybody understand. Now let's say, yes, come to the point here. I'll recap this. We are taking a beaker, we are having some water, and we are having some solute which is of n number of moles. And if we then first, what we have taken, those measurements are took and taken, and it contains of mass m1, which is having number of moles of solute is n, and volume v1, right? Now let's say we are adding some water into that same beaker, of which is of same number of moles, same number of mass, same number of volume. We are adding some water into it. Then due to the level of rise in water, mass changes, which is m2, let's say, and volume changes because water is, there is rise in volume, right? There will be increase in volume, so volume changes. But this number of moles does not change, because here number of moles of solute is same here in the scales also, so it will not change at all. So if we here n is equal to, which implies n is equal to m2 v2, right? Now here m1 becomes, here m1 n becomes m1 v1. Now by the, now by these now by these two particular equations, we can equate that m1 v1 is equal to m2 v2, right? Yes, m1 v1 is equal to m2 v2. That means if we are taking some beaker and adding some water, or if we are taking some beaker, two beakers with same number of solute, number of moles of solute, and with different masses and volumes, then their m1 their masses, their product of mass and volume are equal. Still clearly, if we say ratio of their masses and volumes will be equal. So I hope everybody understood this. This is the thing we needed in this problem, so I have explained in depth or concept. m1 v1 is equal to m2 v2, right? That means here in the previous question which we are been solving from minutes, we got molarity as 10 molar, which means v1, we, let's say v1, that is v1 has stock solution volume, and v2 is given in the last of the question. We were given that we should find out the volume of the 200 ml solution of 0.4 molar, right? That means let's say v into, we got molarity as 10 molar is equal to m2, in the question it was given that in the question 200 milliliters into 0.4 molar, right? Which is 0.4 molar. Now here 10 cancel out to this, and if we write, we can write this as 4 by 10, right? Which becomes 10 to 2 4 are, v becomes 8 molar. So our answer is volume of the stock solution required to prepare 200 ml of solution with 0.4 molar is 8 molar 8 ml. Sorry. Hope everybody understood it.